welcome to the third session of the day. My name is Angèle Christine, and I'm an assistant professor here in the communication department at Stanford. And I'm really excited to introduce this panel on finding story ideas in large data sets. And I think this panel is really important because it asks exciting questions. So yesterday and today, we talked quite a bit about what it means to use large data sets in journalism. We saw many tools and many initiatives doing that in exciting ways. But perhaps we could talk a bit more about how does it work exactly, right? And what does it mean to find stories using data? Does the story come first and the data second? Does the data come first and the story second? Or is it more complicated than that? Second, how does it work for different people? How does it work in journalism? How does it work in academia? I think we're seeing this really interesting moment where journalists start to use data the way academics use data, right? Messy data with complex tools to analyze it. And so what are the epistemological assumptions that go into finding ideas and stories based on these data sets? So we have three wonderful panelists today to help us think through these tough questions. The first one is Meredith Broussard, who is an assistant professor at the Carter Journalism Institute at NYU. Then Sean McIntosh, who is a deputy managing editor at the Atlanta Journal-Constitution. And finally, Jennifer Pan, who is an assistant professor in the communication department here at Stanford. So we're going to have three presentations, and we're going to start with Meredith.
Okay, thanks very much. I'm delighted to be here. I am going to be talking today about a project that I've been working on for the past year as a Tao Fellow, and it's called Bailiwick. And today I'm going to be talking about using artificial intelligence to find stories in campaign finance data. I do want to thank Tao for supporting this research. The Tao community has been really invaluable. And I would also like to say thank you to my collaborator, Jacob Fenton, who is somewhere in the room, who has just been amazing. So I want to start with a truth, which is that investigative reporting is hard. Enterprise investigative reporting is one of the most difficult cognitive tasks that we perform as reporters. And this explains why so many investigative stories are reactive. So they result from a tip from a whistleblower, as opposed to being proactive, resulting from the initiative of a reporter. And in the domain of campaign finance, campaign finance is unbelievably complicated. So I'm going to start by talking a little bit about the domain of campaign finance in the US. And for our purposes here, I'm thinking about individuals, I'm thinking about PACs, and I'm thinking about super PACs. There are lots of other types of organizations, as you can see up on the board here, but we're going to ignore them for now. So if you are an individual, there are limits to what you can give to a candidate. If you are a PAC, there are also limits on what you can give to a candidate. If you are a super PAC, there are no limits on what you can raise, and there are no limits on what you can spend. But the caveat is that you cannot do that spending and fundraising in coordination with the candidate. So that was the finding from the Citizens United decision in 2010. So our investigative reporting is happening against this backdrop of all of the rules in the campaign finance system. And my question was, all right, I want to create a tool that is going to help investigative reporters to quickly and efficiently uncover new story ideas in campaign finance data. And the tool that I built is based on an artificial intelligence idea called an expert system. And the expert system was really popular in the 70s and 80s. The original idea was that it would work like a kind of expert in a box. So you would take the knowledge of a doctor or a lawyer, you would stick it into a box and you could query the black box and it would give you advice, just the way that a doctor or lawyer would give you advice. But the problem is this never actually worked. because human knowledge or human expertise is too sophisticated to be encoded in a simple computational system. So this fell out of favor in the 90s. However, I happened to work on an expert system for the long-distance telecom network in the 1990s. And when I was thinking about creating tools for investigative journalism, I remembered this expert system, and I thought, what if I could hack this? I don't actually need the expert system to give me advice, because I'm a reporter. Like, I can figure out what to do next. But what I do need the machine to do is I need it to visualize data and bring data sets together in a way that I can't do by myself. So it's a human-in-the-loop system. And I was actually delighted that Tamar brought up the idea of human-in-the-loop systems and accelerating a journalist's effort as opposed to replacing a journalist's effort. One of the ways of thinking about the tools that I build is thinking about the difference between a drone and a jetpack. All right, so a drone is a fully automated system, and you can send it out to do its drone thing, and then it will come back. But a jetpack doesn't really work unless it's attached to a person. And when you've got a jetpack on as a person, you can zoom up into the air, theoretically. All right, so we've got this idea of how do we find stories in large data sets. We've got this idea of the expert system. We've got this idea of big data and bringing together enormous data sets. One data journalist working on their own can handle one data set. A team of data journalists can handle 2 or 3 data sets. I'm interested in situations where we have multiple data sets and need to bring them together in meaningful relationships. So the tool that I built for this particular outing is online at campaign-finance.org. So if you want to pull it up, you can see that it's got a couple of features. Primarily, it allows you to search for a candidate or a committee. So this analyzes 2016 federal campaign finance data. In here, we have information for 4,644 federal candidates, 17,000 committees. And the data sources are the Federal Election Commission, Open Secrets, IRS, the ProPublica Campaign Finance API, and Twitter. So we're bringing together all of these data sets in a way that it would be impossible for me to do on my own, and it would be impossible to do using something like Excel or Access. So this is a big data project. It has long since exceeded the puny capacity of my laptop, and it has to exist in the cloud. Now, I was reminded when Jay mentioned in the opening that one of our questions here is how can we reduce the cost of discovery for investigative projects? And I wanted to talk a little bit about what is involved in doing a large computational project like this. So generally you need an architect, you need an editor, you need a writer, and you need 2 to 3 software developers, and you need a designer. I do these projects more or less on my own, and then eventually I write a story out of them and then publish that story with a news organization because I'm an academic. If you were doing this inside of a newsroom, the resource constraints would be different. But this is the second time I've done a big project like this, and I call the paradigm a story discovery engine. It's a tool for discovering stories and data. It takes about $50,000 cash upfront to get a project like this off of the ground. So if you are a small newsroom, it's worth looking at your resources and saying, can we actually afford this? Hopefully that cost will come down in the future, but most of those costs, I mean, I run it really lean, and most of those costs are actually human costs because you can't do a project like this with beginning programmers, right? You need experts, and experts are expensive. So there's kind of a lot of taboos about talking about money, but I think it's an important conversation to have as journalists about, you know, how are we going to pay for these large-scale computational projects. So let's go back to Bailiwick. These are a couple of slides of the front page. You see we have an about, we have a watch list, we have some quick links, and then we have some campaign finance stories. And in there you'll see some instructions on how to use the system. The watch list I want to draw your attention to. I have a pointer. Here we go. All right, so I have a watch list set up where I can watch Donald Trump, Bernie Sanders, and Hillary Clinton. This is a feature that is designed for journalists who are on different beats. So if you're a Pennsylvania reporter, you're probably only interested in people who are running in Pennsylvania races, and maybe you're interested in national races too. So instead of having to search for the candidates in the Pennsylvania races every time you log in, it allows you to have a quick watch list of the people you're interested in. So you can follow a particular political race, you can follow a particular candidate. And the nice thing about this watch list is that you can connect it to Slack, and you can receive alerts when there's a filing related to a candidate that you are following. So previously, there were tools that would alert you to filings via text message or via email, but we decided to use Slack because that's where reporters are a lot of the time now. Reporters use Slack as part of their workflow, and we wanted to reach the reporters where they are as opposed to where we think they should be. And another piece of this watch list is that the system will alert you on filings that are related to any group that is involved in spending on behalf or in opposition to a candidate. So on the FEC site, if you go to beta.fec.gov, which is a terrific interface, you can see, for example, Hillary Clinton's campaign, and you can see people who have supported Hillary Clinton's campaign directly, but in order to see the super PACs who have indirectly supported that candidate, it's much more difficult. So one of the things that we do is we bring together the information on inside groups, outside groups, and opposition groups. Behind the scenes, we automate the connections between those groups and the candidate, and we just alert you on the groups in the candidate's wider world. So let's take a look at what that looks like. Every candidate has allies and opposition. Allies, there are two kinds of allies. We have direct supporters and indirect supporters. Direct supporters are usually, but not always, PACs. Indirect supporters are usually, but not always, super PACs. And opposition are usually super PACs. So just bringing the information together in this easy to understand format is enormously helpful. So let's take a look at what it looks like inside the system. So we've got our candidate here, and we can see allies, and we can see opposition, and you can scroll through those. And then at the bottom of the page, you can see there is a tree map. It's an interactive tree map. You can click into it, and it shows you the individual payments, donations, or spending by the PACs and super PACs. Now, I really like the interactive tree map as a way of understanding the dimensions of spending. So I made another tree map for operating expenditures. So here's the operating expenditures for the Trump campaign. And you can see that placed media is the largest category of spending, followed by, I can't even read that, digital consulting and online marketing. Here's travel, payroll. All right, all of this looks pretty normal because paid media, travel, payroll, that's what candidates spend their money on. But here's something really interesting. Look at this. Collateral, t-shirts, mugs, stickers, and freight. And look at how big that square is. All right, this is actually almost $6 million. That's unusual. All right, every candidate buys t-shirts and sells t-shirts, but that's a really big amount. So that says to me, I wonder what's going on there. So every time that you see, I wonder what's going on there. That's really weird. That's an opportunity for a story. There's another thing that I noticed that was weird, collateral hats. All right, $1.5 million spent by the campaign on hats. That's also really unusual. And then when you add together the collateral for the expenses for the t-shirts and the hats, it's actually roughly the same as the payroll. So this this is worth writing about. All right, this is a lead. Okay, this is going to send me down all kinds of new routes for potential investigative pieces. Even something as simple as, as the hats, but it parses out the information in a way that's easy to understand and triggers the reporter's natural creativity. Right? Reporters are really good at coming up with story ideas. So the story discovery engine is a tool to help them be better at that. It meets them where they are and sends them further along. So the last thing I want to talk about is story ideas. So when I say I do artificial intelligence for investigative reporting, people often ask me, oh, so you make a machine that spits out story ideas? And I used to explain, no, I don't do that. But then I realized, all right, well, what if I did that? So I made something that spits out story ideas. So there's a story idea page. You can hit it from the main page on campaign-finance.org, and you can pull up certain criteria, and it will eventually help you to build a story. So we have a demo in there right now that shows you administrative spending for the American Medical Association. When you're looking for an organization that is up to no good, one of the ways that you look for tomfoolery is you look at their administrative spending. And if a group is spending a lot more on administration than they are on actual programs or on actual electioneering, you know that you've found something hinky or something that you want to follow up on. So we have an example here of how administrative spending stacks up for the American Medical Association. And I am out of time, so I am going to leave you with the ideas of automation, visualization, workflow integration, and human-in-the-loop system. And I hope that you will check out campaign-finance.org. I hope you will register. I hope you will integrate it with your own Slack channels. And I hope you will ask me lots of questions about it in our conversation. Thank you.
Thank y'all for having me. I wish my colleague Jeff Arnshausen could be here, but he had a conflict, and so I'll mostly be talking about his work. At the AJC, the Atlanta Journal-Constitution, I oversee data and investigative reporting, and I'm a big boss who rarely does anything analytical except balance a budget or figure out how to pay for things. Spreadsheets are about the most sophisticated thing I do these days. But I do have the background to champion and advocate for this kind of work. Because I was sort of involved at the beginning in what we used to call computer-assisted reporting. I rarely brag about how old I am, but with this group, I'm really proud, so I'm going to brag for a minute. I was a protege of Phil Myers, and in the beginning of the computer-assisted reporting era, my desktop had less storage than your thumb drive does. I had to analyze national data sets on a mainframe. Ladies, so glad to see you all here. When I used to go to the precursor to NICAR, it is not much of an exaggeration to say that the women of CAR dinner was room service alone in my room. So I'm really excited to see a discipline that people like Sarah Cohen and Rich Gordon and Cheryl Phillips launched really taking hold. Today is a real good example of where I think that can go. For the academics in the room, y'all are going to be like, this is so low rent and unbelievably elementary, but it's one of those examples, real life examples, I think that can really help you understand how we can use this in a newsroom. I'm going to introduce you to our story, Doctors and Sex Abuse, which is a national investigation running through the end of the year, and then I'll tell you a little bit about how we did it.
We have put together data that nobody else has ever done to show the pervasiveness of how many doctors are involved, and that there was a certain tolerance for this behavior among physicians that we just really didn't realize was there.
I remember him kissing me on the lips. And he told me at that time when I was very hazy, it's okay, this is just how we wake you up.
Okay, that's just a little overview. Jeff Ernsthausen was assigned to our Doctors in Sex Abuse project because we always assign a data member to our investigative projects. But we really weren't expecting to use him. We didn't think it was a data project. It wasn't really a numbers project, and wasn't a lot of analysis to it. So it grew out of work our reporter Danny Robbins did last year on a doctor in Georgia who was incredibly dangerous. He was a prison doctor, and female patients in the female prison where he worked kept dying under his care. As Danny researched this, he did what investigative reporters always do. He got more and more curious about documents, and he started reading about the Georgia disciplinary process for doctors who cause problems in their care. Like any curious reporter, he went further than the current story, and he read pretty much all the disciplinary documents in Georgia and noticed doctors who were accused of sexually abusing patients, raping them, violating them, fondling them during exams. He started sort of categorizing and counting, and he eventually estimated roughly 2/3 of the doctors sanctioned after sexual medical abuse in Georgia were sexual misconduct in Georgia were continuing to practice, had been returned to practice through the disciplinary process. So he came and said, let's do a story on Georgia. And I said, well, yeah, Georgia sounds pretty interesting, but is Georgia the worst or the best or what? And so we didn't have the context. So we knew there were problems elsewhere because other news organizations have done some work on this. Seattle Times, Chicago Tribune have done their own states, and we knew we could do Georgia. But no one had really taken it on as a national or regional story. So we thought we would do that. And so we did what journalists do. We sent out open records requests. It's okay, there's nothing there. Open records requests to 56 medical boards around the country and asked them to give us their list of doctors sanctioned for sexual misconduct in their database of sanctions, and how many were for malpractice, and how many for sexual misconduct, and how many for other things. Now, it probably shouldn't have surprised us, but it did, to learn that no state tracks misconduct by doctors or disciplinary actions in any kind of quantitative or analyzable format. They don't have databases. They don't have a way to give you records. They don't have really anything. It took us weeks and weeks to learn this because it's open records request, waiting to get it back. And in the meantime, I was urging Jeff to figure out a different kind of way to get at the story. I was like, let's go to the websites, let's download the documents there. We know many of them post the documents on their website. He kept pushing back and saying, no, let's wait. Maybe the records will come in. We don't want to do that. That's painful. They never came back. So ultimately, we went painful. We began scraping. Those of you who know about scraping know the difficulty of scraping 56 unstructured websites, all with different forms of medical disciplinary records. Some have press releases, some have legal documents, some post lists of actions with links. Rarely are the documents actual searchable text. They're almost always PDFs. Some states don't post a single word. So I thought, this is the hard part of this. Once we get through this, this will be easy. I quickly learned that was not the hard part. We thought once we got the documents, we'd do what Danny had done and read them and categorize them and reach a bunch of conclusions. Now, I remember the weekend I discovered that this was not remotely going to happen. We'd started scraping the biggest states, and we had thousands of records from Texas on hand. And I decided I'd spend the weekend reading through them, sorting out the ones that had to do with sexual misconduct, hand them off to the reporting team. And I'm telling you, I spent a lot of time crying that weekend, a lot of time. First, the cases were horrendous. I can't tell you how horrible they are. The amount of consideration and privilege that doctors get when they abuse women, fondle, violate, and even rape their patients. One story we told out of Texas is a doctor who was accused by 17 women of fondling them, and he's still practicing. 17 independent accusers, and he's still practicing. But the real reason I cried that weekend was that there were many, many hundreds of cases to read in Texas. We had all the medical records, not just the sexual misconduct, because they couldn't sort them out. The cases can be dozens of pages each, legal obscure things, procedural motions, back and forth, updates to the case. And I was getting through roughly 4 or 5 cases an hour. Now, I have a good reputation for analytics, and I kept doing the math, and I kept crying. Because I did not want to go in on Monday and tell my boss that I had figured out in my early analysis that the worst case scenario for completing this story was going to be 12 years. And the best case that I could possibly find, and this was in early 2015, was late 2017. We've got some astounding findings in this case. It is a great story, but y'all, it was not the cure for cancer, and my editor was not going to let us spend 12 years on it. It just wasn't happening. So Jeff had an idea to get me to stop crying, and he often does, and he said he would get the computer to read the documents for us and sort out the ones that related to doctor sex abuse. And so we wouldn't have to read all 100,000 documents that we eventually got. Obviously, I embraced giving this a try. We started on the few states we had in, and Jeff and I were competing. I'd read a batch of cases, and I'd code the ones that related to doctor sex abuse. And he would have the machine learning tool he was developing read the cases and code them. And he was really excited when he told me that he got one of his early passes, and the tool was 80% as accurate as me. And I said that wasn't good enough. The tool had to be way smarter than me, or we were never going to get done. So that's sort of the long, roundabout version of how we got to what we did. Ultimately, Jeff used Document Cloud's OCR to convert the text in 100,000 records that we scraped and collected from websites, public records requests, even news reports. He applied a logistic regression with dummy variables based on the presence or absence of certain keywords to give each case a score for whether it was likely to involve sexual misconduct. So just an example, fondling a breast might turn up in a case with sexual misconduct, but giving a breast exam, probably not a case of sexual misconduct, unless they were fondling a breast during a breast exam. So there was a lot of work on developing this machine learning model to get where we needed. He got it down to 6,000 records that we had to read instead of 100,000. Still took months, but it was doable. And you saw the result early on. We found 3,100 doctors who were sanctioned. More than 2,400 of them involved patient abuse, and half of those are still practicing today. This was a 16-year analysis period, so the fact that half are practicing today shows that way more than half got returned to practice after serious allegations of sexual misconduct. Now, I'll tell you, this isn't really a numbers story. If you read our coverage, you'll understand why. 2,400 cases is not remotely definitive. It is not all the cases. It's a way to pull a collection of cases to allow us to study the story of a broken culture. With 900,000 doctors in America, it's not a big number. We discovered many states handle cases in secret and in private, so the 2,400 we discovered, probably a small fraction of the problem. Definitely, we know a fraction of the problem, we just don't know how small or how large. We learned a lot of hard lessons along the way, and I can answer questions about those during the question period. Let me give you just a quick commentary from one of our reporters who, I will tell you, y'all talked earlier about reporters adopting this. None of our reporters would have suggested this or adopted this, but they ended up loving it because the tool Jeff built not only tagged the documents we needed to read, but gave us a system to search and annotate and do a lot of work to get to the actual stories once we had the cases we wanted to examine. So this is from Carrie. She said, the tool that Jeff built gave us a very comprehensive picture of what had been happening with sexual misconduct cases in all 50 states. This had never been done, ever, and it couldn't have been done without this tool. The technology also allowed us to get beyond the comprehensive and identify patterns because we could search the text of the documents. We could search for certain words that helped us find cases to zero in on: abuse by psychiatrists, abuse involving children, abuse where drugs were offered in exchange for sex. We could find cases where hospitals were involved in cover-ups and where medical boards reinstated doctors after revoking them. We were able to quickly look at one state's approach and compare it to other states, leading us to the state disciplinary boards that needed special scrutiny. She said the quick take, the technology allowed us to do old school reporting on a massive scale and shine a spotlight on a phenomena that was buried in thousands of hard to find documents. I do hope you will take a look at the stories, especially if you have a daughter or a mother or a wife. It is a horrifying and widespread problem. Thousands of doctors forgiven. It really breaks our heart. We're very proud of the work Jeff did to let us tell this story because we couldn't have told it without him.
On this map, the countries that you see in red are authoritarian regimes. We can quibble over some of them, but roughly speaking, these non-democratic countries are places where there are no elections, or if there are real elections, they're not free or fair. They're places where media is controlled by those in power, and where information does not flow freely. My work focuses on studying these countries, and in particular, studying how these regimes control the spread of information, how they control the production and dissemination of information, and how they collect private information about individuals. All of my work is quantitative. I use statistical methods, computational techniques, large-scale data sets that are very messy and complex, and mostly because this is out of necessity. When I study regimes that control information, it's because they don't want people to know what's going on in these countries. So they don't make it very easy to figure out what's going on. And in often cases, we have to look at digital trace data or remote sensing data, leaked data sets, in order to get a view on what's going on in these opaque regimes. So when it comes to finding stories in large data sets, or more precisely in my case, answering social science questions with large data sets, I want to talk about three things that have been really important for my research: serendipity, substantive knowledge, and falsifiability. Statistical and computational methods are necessary and very, very important, but I'm coming from social science where a lot of folks are getting really teched up. People know R, people know Python, you know probability theory, statistics, linear algebra, calculus. Everyone is getting these tools and techniques. But when it comes to really figuring out what's going on in the world and having confidence that what you find is really what's going on rather than a figment of my overactive imagination, I want to talk about serendipity, substantive knowledge, and falsifiability. So serendipity. When I was a graduate student back in 2010, I started working with a faculty member and another grad student on developing algorithm to classify Chinese text, estimate category proportions of Chinese text. So there are a lot of computer science algorithms that classify individual documents. Is this email spam or not spam? But as a social scientist, I'm often interested in category proportions. So in the last presidential debate, what proportion of statements pertain to policy positions? What proportion pertain to other things? Of the tweets about the presidential debate, what proportion supported one candidate? What proportion supported another? And if you use individual classifiers to do this, even when those classifiers have really high precision and recall, when you aggregate up, the proportion estimates could be off. So we were working on a method for Chinese text to estimate category proportions. And to do that, we needed a lot of Chinese text. And so we went to social media. We collected tens of millions of social media posts, and so we have the text of the post and the URL, where they came from. And at some point, we were running into weird things with our data, so we wanted to go back to the URLs to see what we were collecting. Were we collecting only social media posts, or were we collecting other things? And we went back to those URLs, we often saw messages like this that said, sorry, the host you are looking for does not exist, has been deleted, or is being investigated. In other words, we were finding that the content we had collected were being censored by the Chinese government. So we're like, wait a minute, we can actually study censorship in China because we have the content of what they censor before they censored it. At this point, we could have continued on our algorithm, developing the algorithm, which we did, but we shifted really quickly to studying censorship in China. And that's where serendipity came in, which is that we were on a path, we collected a data set to do one thing, but then realized that it actually was much better to use that data to answer a different question. And so it required flexibility on our part and some luck. So we had this data. In order to make sense of it, the first thing we did, there was like tens of millions of posts, so we didn't really want to read it. So we first tried to use unsupervised machine learning algorithms like topic models that Jonathan mentioned to figure out were there topics that were more censored or less censored. We used keyword algorithms to figure out were there sensitive words in the censored posts and other words in the non-censored posts, because that's the received wisdom about Chinese censorship. And what we found is that these methods didn't work at all. For example, a topic like weapons in Taiwan, which is, we think, very sensitive, had the same rate of overall censorship as a topic about a soap opera, a popular soap opera. So at this point, we could have concluded that the Chinese government just randomly censors for 13% of all content. We didn't do that. Instead, we actually read thousands of the posts, and I conducted interviews with people involved in censorship in China. So I interviewed government officials, people in internet content firms, and what we realized is that the way censorship is done is different than what we thought. So we were not studying the Great Firewall, we're not studying, keyword blocking, we're studying removal of content after it's already appeared online, and this is what most Chinese people are consuming. And how censorship works in that case is by virality. So if a lot of people are talking about a particular topic, the internet content provider will go see what is so popular right now. And if it's an objectionable topic, then everything will be deleted. It doesn't matter exactly what people are saying, as long as it's a topic that's gone viral, there's a burst of discussion, everything in that burst is removed. So we see things like this. So both of these plots are time plots where on a 6-month period, everything in gray are all of the posts about a particular topic. So these are 2 different topics. And all the areas shaded in red are topics that are deleted. So first thing you can see is that there's a low level of censorship, around 10%. And that could be either the government or just people removing posts that they made. And then you see some bursts of discussion have no censorship, so censorship is still low. And then other bursts of discussion, almost everything is removed. And that's what's happening with censorship in China. It's not by overall topic, it's not by keyword in this case, it's by looking at bursts of virality and removing objectionable bursts. And what we find is that the bursts that are removed are all those that pertain to on-the-ground mobilization, real-world collective action. It's not the case that if you call for people to protest on social media in China that you'll be censored. If you talk about an ongoing protest, even to criticize those protesters, you'll be censored. So that was the finding from this, and that really relied on us getting substantive knowledge. So knowing the language, understanding how China works, talking to people involved in the censorship apparatus. But we had this finding, but we were worried because when it comes to large-scale data, we can find lots of patterns, and we as human beings are really, really good at finding patterns. So we were worried that maybe we had just found this pattern in the data and convinced ourselves of a story that was compelling and counterintuitive. So what we did instead was make ourselves vulnerable to being wrong, knowing what we would see in the data if we were wrong. So the prevailing view is that China censors criticism of the state. So if you criticize the top leaders, if you criticize the party, the regime, its policies, you'll be censored. What we were arguing is that China will censor things related to collective action, which means that even if you have posts which are praising of the regime, that'll be censored if it's related to protest. If you have posts that are very critical of the regime, if they're not about collective action or protest, they'll remain online. So we actually went a step further and tested this in a randomized experiment. I think probably for journalists, you don't have time to do a randomized experiment, but even with observational data, the important point is to know what you would see in that data if you were wrong. And if there's nothing you would see in the data to prove you're wrong, then what we would say is that maybe there's a chance that you're making a story that might not actually exist. So with serendipity, substantive knowledge, and falsifiability, these issues have come up again and again as we are working with large-scale data. So right now we're working with a leaked leaked archive of emails from propaganda departments in China that have been released publicly. They're really messy data, and to make sense of them, we had to be really flexible in jumping on it right away to try to figure out what was going on. Try to understand what propaganda departments were doing in generating this data, and also, again, making ourselves vulnerable to being proven wrong. So for me, as a social scientist, when it comes to working with these large-scale data sets, the technical methodological fluency is really, really important, but it's not enough to make sure that the stories that we're finding and the things that we're uncovering about the world are really what's going on. Look forward to your questions and comments.
Well, thank you for these great presentations. And so perhaps to get the discussion started, I would ask the first two panelists to perhaps respond to the last presentation's question. So what about being proven wrong? And how do you address that in your own practice?
Well, we, of course, with our model, we had the scale where it was telling us it was, a score of 1 to 100 was basically it was or it wasn't a case of doctor sex abuse. We, of course, looked at the low-scoring ones and did a sample of those, did a random sample back-checking. But we were not looking for the kind of statistical precision that really a lot of analytical journalists are. We were looking for a big bucket of cases, really. We were just trying to get to the cases so that we could read them and understand them. So we kept having this discussion about, is this case a fish or is it a flotsam? And finally, Jeff said, how much fish are you willing to lose and how much flotsam are you willing to read to get at the right answer? And I said, I've got to publish. That's the most important thing for us, is that we have to get this story in the paper in, a reasonable amount of time. So I said, if we read a lot of flotsam, it'll kill us because we won't publish. If we miss a few fish, it won't be the end of the world.
Yeah, interesting.
I'm glad you asked about being wrong, because I actually made a note about that. I wrote down the idea of making yourself vulnerable to being wrong. And I think that's really important to do as a journalist. Sarah Cohen mentioned yesterday that investigative journalists take a lot of notes and do a lot of queries that end up being nothing. And I think that's really important. There are a lot of ideas that I come up with that turn out to be totally wrong. And I think that I try and build tools that allow for the possibility of being wrong. So that's one of the reasons I'm not interested in building tools that say, gotcha, you definitely committed campaign finance fraud, because that's really ambiguous, and you would end up making a lot of false accusations for people who are entirely innocent. I am more interested in building systems that kind of surface the weirdness and allow journalists to follow up and find out what exactly is going on. Because we're not always going to be right, and that's fine. That's the process of exploring ideas in investigative journalism.
So I think that that's exactly what was fascinating about these three papers. It's a kind of interactive process that you all went through, right? Like using quantitative data, but then checking against kind of more qualitative evidence, then going back and forth. And so that's what's, I think, really exceptional about these three presentations. So we'll open up the room for questions. The mics are there. Perhaps you can walk down there.
Hi. First of all, I wanted to compliment the organizers. This is an all-women panel. I don't usually see this, and that's fantastic. I had a question on data integration. I think both Jen as well as Meredith, you were both speaking about disparate data sets coming together. Can you speak about what integration methods / tools / indexing, what do you actually do underlying the infrastructure before search queries can run? And explain a little bit of that.
I do really primitive entity recognition. I I have a conceptual object model that I overlay on top of a literal object model, which allows me to tie together entities across data sets.
So for us, a lot of time is actually spent turning unstructured data into formats that are easy to analyze, whether it's CSV files or other sort of files, and then in that format, that's when we merge. But in text data, actually, I don't know if this is just a disciplinary norm, but we usually just treat all text as bag of words. Maybe you remove stop words, because we're looking not necessarily for specific individuals or events, but categories of things that are happening. How much time, what proportion of things is this versus that. We also use some entity recognition methods, but that's to overlay additional variables on top of the data sets. And then, so maybe more directly in merging, we use R and other statistical tools to merge.
Following on that question about how do you determine if you're wrong or not, or being vulnerable to that, yesterday a lot of people were talking about sharing data and sharing code, and I'm wondering if you could talk a bit about that, because that's often the way you can discover if you've missed something.
So I would actually say it's a slightly different point. I think reproducibility, sharing data, sharing code is very, very important, but falsifiability is not just making data public, but being clear about what you expect to find in the data, what patterns you would see in the data if your theory or if your explanation about the world is right, and what you would see if your explanation were wrong. In some ways, having data public is essential to making that happen in a community so that others can probe on your hypotheses, and even if the initial work did not, have falsifiability, someone else can come along and test it in that respect.
And wouldn't that fall into the category of sharing code?
In part, it can, but I don't know that sharing code solves the entire problem, because the falsifiability issue is also just theoretical. It's about knowing what you would expect to find versus not find. So knowing how someone analyzed the data is important, but as I think someone on yesterday's panel mentioned, you don't see everything they tried but didn't put in their final code file or code book, and all the kind of subsets of data or data subsetting or merging or things that they did in the background, all the sausage making that you don't see at the end in the code related to what they presented. So I think open data, open code would make it easier, but it's not the same thing as just knowing, given your explanation, what would you see in that data, and do you actually see that? And what would you see if you were wrong?
So I would also draw a distinction between reproducibility and transparency. Transparency is a really good goal to strive for on the way to reproducibility, and sometimes in journalism, transparency is really as far as we can get. It is a lot of work to make your code open, and it is a lot of work to share and proofread your code. We don't always have that time. We don't always have that luxury. So one way of thinking about it is to think about an investigative project as a puzzle. And your readers should be able to understand from your entire package what the pieces were, what the puzzle pieces were that you used to assemble your story. And they should be able to assemble those puzzle pieces and draw exactly the same conclusions that you did.
I have a question for Jennifer and one for Sean. Jennifer, you found some pretty surprising things in censorship in your reporting, in your studies. Were there other surprises about patterns of censorship or the nature of it that you'd like to mention? And then Sean, how the heck are these doctors still operating?
In terms of patterns of censorship, I think one thing that we are really surprised by is that things that go viral online, even politically sensitive ones, were not censored. The Chinese regime only cares if people are mobilizing on the ground. They only care if people are, out there, and organized, even if there are millions online who are behind something that goes viral. That's not enough for them to censor. So that was surprising. Recently, we've been doing work on propaganda or government-led astroturfing in China to see what fake posts the Chinese government makes. And there we found something very surprising, which is that they never engage in argumentation. So if you ever see online people who are staunchly defending the Chinese regime, we don't have evidence that that's actually government-led. Instead, the government just puts out all this positive, happy things to distract from what's going on.
So how are the doctors still operating? A couple of big picture themes, but it's cultural. It's the Boy Scouts, it's the Catholic priests, it's universities, it's all these organizations that have struggled and grappled with sexual abuse and transparency issues, and a whole culture of cover-up and lack of transparency. Doctors are generally regulated by other doctors. They're largely men. The problem is largely men against women, although it is children and it is young boys and occasionally grown men. The other thing that is was really quite astounding to me, maybe not that it happened, but that the extent that it happened, is that the medical profession has adopted a position, unlike the rest of the society now, that sex abuse is an illness, not a crime. And so if you're a doctor who abuses a patient, then you get to go into treatment and have psychiatric care and return to practice. And it happens in the vast majority of cases. There's a blossoming industry that's grown up over the country that treats doctors with impairment issues. It grew out of doctors who had drug abuse problems or alcohol problems, and of course that is, I think, viewed by society as a curable impairment. Now they have expanded into what they call sex addictions and sexual violations, and they treat them. They do have a rigorous treatment program and a monitoring program after the fact, but the vast majority of doctors who are accused of sexual misconduct go through treatment programs and return to practice.
This is a question for Jennifer. I think some of your methods were almost like investigative reporting in ways that you didn't highlight. One is, could you talk about paying people to send social messages and see how, and explain to the crowd what that was? And then I also think that you sort of got the censorship manual by having your own firm, the social media. So maybe there's a famous example in reporting where if you want to figure out corruption in Chicago, start your own bar, call it the Mirage, and then write about what unfolds. So could you tell people about that?
Yeah. So in the second study, which was an experiment, so basically we had, figured out, we came up with this theory in the observational data and the large-scale data. We wanted to see if it was actually right. And so we did an experiment where we made posts that were supportive of government, critical of the government, in bursts about collective action and in bursts about other popular topics to see what the government actually deleted. We validated our finding, but that was the point to falsifiability, is that we could have been wrong, and if we would have been wrong, that would have been great for us because we could have contradicted ourselves and made another paper out of it. And then the point around the firm, so another part of figuring out how censorship happens is that we set up our own website in China and installed software, back-end software that a lot of online forums use in China to figure out how does censorship work, what tools on the back end do they have. We talked to their customer service, and unprompted, they gave us recommendations for how many censors per active users we might want to consider if we're starting a site. I think these are tools that investigative journalists are probably much more familiar with than us as social scientists. And I think that where we're coming from is that we have all these tools to analyze data. Let's just use those tools. But we really need more intuition about what's going on in order to know what to test and not to just be blindly looking at the data and trying to find patterns.
And Jennifer, can I ask, how long did that take? That particular experiment? How long did it take to put together and implement?
So the experiment only took 1 month. Well, maybe that's a really long time for you guys, but it took 1 month from
that's fast.
start to finish. This project took a long time because we spent the first 9 months developing the algorithm, not knowing that we were studying censorship. But and then it took a long time to figure out how to study censorship when we weren't using the human method or getting the substantive knowledge.
My question's for Meredith. You mentioned a tremendous cost involved in setting up a large data scale project like that. I was wondering, do you think there is is that model kind of replicable enough to warrant an investment in potentially like a scalable system that other journalists can just use and kind of deploy onto a different data model? And yeah.
I don't know. I'm really interested in the idea of what kinds of resources does it take. Something I forgot to mention is I was talking with another conference attendee about what it takes to do investigative projects in her domain, and she mentioned that the startup costs for an hour-long news documentary, are like $400,000. So that made me feel a lot better about, oh, hey, like mine is kind of cheap. But you can achieve a lot of economies of scale inside the newsroom. I mean, working on something for a year, for 10 months, like, is not an insignificant investment. And there was a Mother Jones story recently where the reporter went undercover as a prison guard, much like what my colleague Ted Conover did for his book about being a guard at Sing Sing. And I think the estimate I saw for that was about $350,000 in organizational costs. So can we do this at scale, and is there any value in building things that other reporters can reuse? I did this on my first story discovery engine. I built a system that analyzed textbook shortages in Philadelphia public schools. I published it as open source. You can see it, you can download it, you can use it to perform that same analysis on your local school system. Nobody has done that so far, I think because it's just hard.
Okay, so on these last words, important words, join me in thanking the panelists.